This is step number 3 of the final project of the intercom system. And now that we have initialized all the hardware components on the Arduino, we're gonna write the code so we can send the output messages to the Raspberry Pi when we have something that happens with the hardware. So actually here we have just the button code to write. And so first of all, I'm going to save this as intercom step 3. Okay, save. And let's actually open again the protocol that we have written here. So for me it's right there. So we can see here from Arduino to Raspberry Pi, we just have the button pressed command to send with \n. So that's what we are going to do. And so, well, this we have already done that before, but I'm still going to do it again. Right there is to read from the push button and detect when we have pressed on the push button. So I'm gonna create 2 or 3 new variables here. Let's do that right there as the global variables. So unsigned long last time button changed, which is equal to millis or 0, it doesn't matter. And unsigned long debounce delay, let's put 50 milliseconds. You can adjust that a bit more or a bit less depending on how it works with your circuit. So this is gonna be for the debounce mechanism. And then I'm gonna also add byte previous button state. And the previous button state, I initialize it here. Previous button state is equal to digital read from the button pin. And of course I do that after I have put the pin mode with button pin input. Now in the void loop, so in the void loop we can read from the push button, but before we read from the push button, we're gonna do the debounce mechanism to be sure we can read from the push button. So unsigned long time now is equal to millis. So we get the time every time we enter the void loop, which is going to be pretty fast. If the current time now minus the last time the button state has changed here is greater or equal than the debounce delay. So if we have spent enough time since the button has changed for the last time, then we can read the button state. So byte button state is equal to digital read button pin, and then we can compare the button state, so the current one we read, from the previous one, so from previous button state. If those are different, then we have either pressed or released the button, and in that case, first we can update this. So the last time the button has changed is actually now, so we put time now. We also say that the previous button state is the current one for the next time we enter the void loop. And then we can do an action, so we can check if, for example, button state is equal to high, which means that we have pressed on the button because we have a pull down resistor, and if it's low, we have just released the button. But here we want to know when we press on the button. And once we have this, we can send to serial. So send a message to serial. And to send the message to serial, I'm gonna initialize serial here. Serial.begin with this baud rate. We're gonna use the same in the Raspberry Pi. Let's do while not serial, okay, for compatibility with some Arduino boards. And here I'm gonna add something else that I didn't do before, and we probably won't need it in that project, but that can be a good best practice to add, is to do while serial.available is greater than 0, you do serial.read. So read is gonna read only 1 byte. So here we just read it and we don't store it, we don't do anything with it. But basically what we do here is we just clear the input buffer. If you remember with serial in Python, you have the reset input buffer function. We don't have one in Arduino, but we can easily implement it by just checking that, well, while we still have bytes on the input buffer, we read them, so we clear them from the buffer. So we are sure that when we start here, we don't have anything in the input buffer. And so I said for this project it's not going to be useful, because why is that? Because when we start the Python program and we initialize the serial communication with the Arduino, well, the Arduino is going to be ready first. So by the time that we enter this block of code and that we enter the void loop, the Python program is still not gonna be sending data, okay? So this, it should not be called, but that can be a best practice for other projects of your own, okay? If you want to make different boards communicate between each other. And now that the serial is initialized, let's actually do here serial.println, okay, because we need the \n at the end, button pressed, exactly like that. This should be it. Let's check. So we have those three variables here. We correctly initialize the state for the button. We read the previous state. We have the serial initialization, and then we read from the push button with the debounce mechanism, and when the button is pressed, we send button pressed. Let's connect the Arduino. Okay, let's now, so it's good. Let's now upload the code. And well, actually I have forgotten, so I just made a typo here. Uploading, down uploading, let's open the serial monitor, and I'm gonna press on the push button. So starting, press on the push button, button pressed, button pressed, button pressed. So every time I press, I receive a button pressed message on the serial monitor. Everything is correct. And that's the end of this step number 3. We can now focus on the input commands that we receive from the Raspberry Pi.